Hello everyone. Today I will introduce you about the word problem on set. Word problem on set are solved here to get the basic idea how to use the property of union and intersection of set. So basic word on the set. So it means that on this time when we solve in Word, we just do not solve by our diagram of line. It means that you just write all some property of our set, like the Morgan rule or like the distribution law or something. This is the word problem in our set, and all some exercise is uh, give you about the problem, and we will solve about this word problem on set by the basic idea to use the property of union or intersection or the complement or the difference between set and set or symmetric difference between set and set or something. This is the word problem which I will introduce you for the new point in our set. Uh, Two video, the previous two video which I produced for you. The first, it's talk about like I just said, it's talk about the uh, definition of set and the type of set. And the second video, I talk about the set operation. And the next is talk about the word problem in our set. So now let we go to see our example on the word problem of our set by using the property of union or intersection or complement or uh, different or symmetric different and about Cartesian product. So we use all about this point. Now we go the first one or the first example. If I let A and B be two finite sets such that A and A, the cardinality of A is equal to 20 and the cardinality of B is equal to uh, 28 and the cardinality of A union B is equal to 30, 36. Now they want us to find about the cardinality of A intersection with B. So if we want to find about the A intersection with B, it means that we should be know what is the formula which we use. It is relate to an A and B and A union B and A intersection with B. So we have our formula or our property is an A union B is equal to an A plus an B minus an A intersection with B. So this is our uh, problem we want to find. So we should be write our property first, and then we find some point which didn't have in the hypothesis or the exercise they give us. So this is we find about the end of A intersection B. So A, the cardinality of A intersection B is equal to NA plus NB minus NA union B. This is the kind of our formula or property that we can expand to this one. So NA we know, NB we know, and A union B we know. So it is equal to 20 plus 28 minus 36. So it is 48 minus 36 equal to 12. So this is our uh, this is our finding about the cardinality of A intersection with B. And this is the kind of our solving. We use this formula and then find. And point two. Point two, if n A different B and NU and A union B equal to 70 and A intersection with B equal to 25. Then find the NB. So how can we find the NB in here? How can we find the NB in here? So if we want to find the NB, we should be know this is relate to the NA intersection with B, union B and A intersection with B. But we should be know about the NA or like NA different B. A different B. A different B. What does mean A different B? Our A different B. What does mean about A different B for tomorrow or the first which I told you about A different B. A different B, it means that have about A union B. A union B minus or different with A intersection B. Or something we just write about the A different B equal to A intersection with B complement. So this is our property of A different B. And but when we have A different B, we have N union A union B and A intersection with C. So we could be take all these points like that relevant to A different with B. So how is the property that we combine from this one? Now we just go to this one. Use the formula of this one. NA, it means that the number of A union B is equal to the number of A different B plus A intersection B plus it means that A n of B different A. Why we use this one? Because A symmetric different B equal to and example A union B different A intersection B, but this one is equal to A, like this one. A is A union B intersection with A intersection B. This one, this is the kind of different. And the next we just, but this one is equal to A, this one is A union B, A different B, or B different A. So we expand this one and we get this one, and this one is our expand of symmetrically different. Now we get our N B minus A, or B different A, is equal to 27. But NB is equal to this one. NB is equal to NA intersection with B plus NB minus different A. So it means that NA intersection with B is equal to 25, and this one is equal to 27. Now we got NB is 52. This is our to find about the meaning. So we should be know about know exactly about what is the meaning of A different B, A union B, A intersection B, and something. So all this one is our kinding to solve about the word problem in our the word problem on our set. And point three, they said in a group of 6 people, 27 like cold drink and 22 like hot drink. Each person like at least one of 2 drinks. At least it means that each person like at least one. So sometimes they like only one, and sometimes they like both. Each person like 2 drinks. At least one of 2 drinks. So this one, if we want to show in our Venn diagram, we just draw about the diagram first. This one, yeah. But they said that 27 like a cold drink, and 42 like hot drink, and each person like at least one of 2 drinks. So each person have some like about the this cold drink. So our this one is 27, this one is 42. So I think this is example. This is a cold drink C. This is a in hot drink. So cold drink is 27, and about the cold drink, the cold drink is 42. This is the kind of our drawing about the Venn diagram, and each person like at least one of the two drinks. So we can find about the in our word problem, and how many like both of coffee and tea. And this one is the first we let A set of people who like cold drink, and B set of people that like hot drink. So a cold drink, it means that uh, in group of 6 people. So in group of six people is the number of A union B. A union B is all of uh, 60 to 60 people, and NA is equal to 27 and B is equal to 42. And then we find about the, and the first we should be used about this one, about this formula of N A union B is equal to NA plus NB minus NA intersection B. So we find this one, this as we got about this property, and now we got about the NA and B and the NA union B. So this one is 9. So this one we got 9. If we got this one is 9, it means that this is 16. This is 16 and this is 32. This is the kind, like a cold drink is only a cold drink is only 16. Only cold drink is 16. Only hot drink is 32. And about the cold drink and the hot drink is 9%. 9%. So if they want you to tell them about just only, or they like about the cold drink but not like about the hot drink. Like cold drink but not like the hot drink, it means that they like cold drink but hot drink, it means that they like about example A different B. So A different B is equal to what? Is equal to A intersection with B complement. And what is A and what is B complement? So we should be expand for this one. But in this case, we have about the we just to find only about the both of cold drink and the hot drink. Cold drink is the coffee or something, hot drink or everything. So this is the tea and the coffee. It means that intersection between the cold drink and in the with the hot drink. So this is our and the next 4. There are 75 students in art class and 57 students in dance class. Find the number of the student. So it means that they want ask us about the student in the class. If we have about 35 students in art class and 57 students in dance class. So now we just who are either in class or in dance class. Find the student, find the number of the students who are either in the class, art class, or in dance class. So when two classmates at different 2 hours and 12 students are enrolled in both activities. When two classmates at the same hour, this is the condition that they tell us what is the problem when two class meet at different hour and 12 students are enrolled in both class. So in both class. So it is the NA, like NA, like NB, and NA intersection with B. So how can we find the NA union B? This point. We got already this one. And we find the NA union B. NA union B, it means that we got about 80. When two class meet at same hour it means that the same hour, the class is the same hour. It means that they have only class in art and class dance class. So other students cannot be join each other because they have different class. The same like example, if you study math and soft skill or something, but math and soft skill is the same time. We start from 7 to 9 and soft skill start from 7 to 9. So other students that they choose both of these subject, they cannot study in both of subject. They should be choose one of these two subjects. Which one they go to study, or if you want to study math, you cannot to study in our in soft skill. If you choose soft skill, you cannot study in mathematics. This is the property of our thinking, like when two class meet at the same hour. It means that they start from 7 and start from 7. Start from 8 is start from 8, and in at 10 or in at 9 is the same of this hour. So we got about the N A junior intersection B is equal to empty set, because this is disjoint class. We cannot join our class with other student. If art class and dance class have different hours, so other students that they like both of these class, they can join. Example, I think art class start from 7 and dance class start from 10. So the dance class can be joined at start class, and the art class can be joined with the dance class. So now it means that the cardinality of A intersection B is equal to 0. So we got NU, this one. NU, sometimes we can cross it out because this is disjoint set or disjoint class. It means that the class is different, cannot join each other, the student. So the N intersection, the cardinality of A intersection B is equal to 0. So just we use about the property of A union B is equal to NA plus N and B. This is our property. And the next, in our group, in a group of 100 persons, 72 people can speak English and 43 can speak French. How many can speak English only? How many can speak French only? And how many can speak both English and French? So in group of 100. In group of 100, it means that we have N. They assume that NA union B is equal to 100. This one is 100. And this one is NA. NA is equal to 22. And B is equal to 46. 3. This is our hypothesis. So how can we find about the only English? Only English, it means that what is like example, like I write NA minus B, it is minus B is equal to what? Equal to NA minus or something because A minus B or NA like is equal to A intersection with other one. So we should be expand about this one. Sorry. So we got let A is a set of people who speak English. B is a people who speak French. A different B, it means that who speak only English, not French. B different A, it means that speak only French, not English. And A intersection B, they speak both. And now we have, it means that NA is 72 and B is 43 and NA union B is equal to 100. So NA intersection with B is equal to NA plus NB minus NA union B. So we got about 15. There are number of persons who speak both French and English is 15. And this one is NA. We talk about the NA. NA it means that NA plus NA different B plus NA intersection with B. But this is our cardinality. This is only English. This is English and French. So when we want to find about this one is find about the English and only in English. So only English is equal to NA minus NA intersection with B. So we got 72 minus 15 equal to 57. But and about the only English, only French but not English. So is equal to NB minus NA intersection with B is equal to 28. So from this one we can